I bet you I can draw my ball faster.
No, you can't. My ball's heavier. It's definitely going to fall faster than yours.
My ball's smaller. It's going to fall faster than yours.
No, it's not.
Hold on a minute, boys. Both balls are going to fall at the same rate.
Really?
What? How? I don't believe you.
Well, yeah, I'm right.
Prove it.
Prove it.
Okay.
Today we're going to teach how to calculate the velocity of an object in free fall.
First, we need to find the equations that relate to this problem. So we start out with kinetic energy is equal to potential energy because energy is never created nor destroyed. So the equation for kinetic energy is 1/2 mass times velocity squared, and the equation for potential energy is mass times the force of little g times height. And we set these equal to each other because, again, energy is neither created nor destroyed. So the masses cancel out, and that leaves us with 1/2 velocity squared is equal to the force of little g times height. Now we multiply both sides by 2, giving us velocity squared is equal to 2 times the force of little g times height. Now we take the square root of both sides, leaving us with a final equation of velocity is equal to the square root of 2 times the force of little g times height.
Step 2 is to plug in your knowns. So we're going to take the equation from our previous step, which is that velocity equals the square root of 2 times the force of little g times the height. So when we plug in our knowns, we get 2 times little g, which is equal to 9.8 meters per second. And then we multiply that by our other known, which was the height of the object that was dropped, which that height was 6 feet, but that converts to 1.83 meters. And then we take the square root of all of that. Step 3 is to solve for your unknown. So we take the equation that we already came up with from step 2, and we use that to solve for our velocity, which is our unknown. So we multiply our two values in parentheses together, and then we multiply that by 2 to get the square root of 35.9 meters squared per second squared. And we take the square root of that to get 6 meters per second.
Our fourth and final step is the unit check. So we started off with an equation that was the square root of a value in meters per second squared times a value in meters. So we multiply meters by meters per second squared, giving us the square root of meters squared per second squared. Now we take the square root of that and we get meters per second.
In conclusion, both balls were traveling about 6 meters per second when they hit the ground. So if you use our original equation, that equation is true for any object in free fall, where the velocity is equal to the square root of 2 times the force of little g times the height of that object. Note that in free fall means that the only force acting on the object is gravity, and air resistance is negligible.